Hello everyone and welcome back to the last part of lecture 2. Now we are going to discuss the five remaining principles, and now we will move to the sixth one. Don't trust services. So many modern web applications rely on third-party services to provide additional functionality or access, like to external data. Okay, so examples here include like payment processors, include mapping services, authentication providers, or even analytics tools. Okay, so from a security now perspective, this principle states that no external service should be trusted automatically. Okay, so the application must always validate the data, and it receives like if it receives something from the third party like services, even that these services are well known or they are widely used, like double checking and validating the data is very important. In addition, the third party now services should not be, I would say, given high level permissions within the application. This access should be limited to only what is necessary. So this approach helps reduce the impact, I would say, of failure, and also impact of misconfiguration or compromises in external services. Okay, so in secure design, trust is never assumed, it is always verified. Okay, if I want you to keep something in mind from or based on this principle, is that whatever is external doesn't mean it's safe. Okay, so this is the main point. Next secure design principle is separation of duties, and the primary objective of this principle is the prevention of fraud and errors. So this objective is achieved by distributing tasks and associated privileges for specific business process among multiple users, instead of like giving too much power to a single individual. Like for example, in an e-commerce like application, a regular user should not like be an administrator. Okay, so if they were, let's think of it, they could alter orders, for example. They can even give themselves like products or something. So the reverse like is also true. An administrator now should not have the ability to perform actions that meant to be for, I would say, for customers. Like let's think of ordering items. Administrator must not order items from the front end of the website. Okay, so by separating like this responsibility in this way, systems reduce the risk of both, I would say, intentional abuse and accidental like mistakes. So separation of duties ensures that no single user has complete like control over critical processes. And the main idea here is that power should be divided. It should not be centralized, okay? And here is just an example. So in this diagram, what you can see is a real-world example, okay, of separation of duties in business process. Here, what we have is the process is divided into multiple tasks, okay, and each step is handled by a different person with, I would say, with different role. Okay, so one person is responsible for like writing purchase order, for example. A second person here is responsible for approving that purchase order, and another one is there to approve the invoice. And finally, a different person again is there to is responsible for signing the check, okay? So each user has separate account and specific set of permissions that only allow them to perform their assigned tasks, so not more than that, okay? So no single person can complete the entire process alone. So this kind of separation reduces the risk of fraud because it requires collision, okay, between we have here multiple, like you see, users and different roles and different people maybe are involved in this like process, okay? Uh, so if let's say like uh, any errors show up only with a particular account, let's say, okay? So this also reduces errors again, since like multiple individuals review and approve different stages of the process. And this is exactly how we like this separation of duties protects real systems in practice. And so this is just an illustrative example with multiple roles and how we are separating the duties. So the core or the main idea here is that critical action like actions should require multiple roles, okay? So moving forward, now what we have is the eighth secure design principle, which is avoiding security by obscurity. So in security engineering, security like through obscurity means relying on the secrecy of the system's design or implementation. Okay, uh, this is the main idea. In other words, the system may have, I would say, real vulnerabilities, and that can happen because, like I was mentioning, the idea is to rely on this secrecy of the system's design or implementation as the main, I would say, method of protection. And if we do this, like the system may have real vulnerabilities, but the designers assume that like attackers will not succeed in simply because these flaws are hidden. Security experts strongly reject this approach, okay? And obscurity should never be the only security mechanism used to protect a system. For example, if an application is only secure because it's like administration, I would say, URL is hidden, then the application is not truly like secure in this case. So a secure system should remain protected even if its structure or functionality is known. So popular security controls, like for example, authentication or like access control or authorization must be in place rather than relying on like secrecy to prevent attacks. So if we want to summarize again this like slide, mainly if we have something hidden, that does not mean it is secure, okay? So this is the core idea. And here is a simple real-world example of security by obscurity. So imagine now hiding the key of your front door uh, under a rock, or let's think that it can be even hidden under the welcome mat or on the top of a railing. So the key is technically hidden in this case, okay? But it's still right outside the door, okay? So most people might not find this like if the key immediately if they want to look for it, but if we have a dedicated attacker, he knows exactly where to look, okay? Because he even think where as a human we can think and he can find it, okay? So this kind of security relies on the hope, I would say, that no one will search carefully enough. Okay, so and in security engineering, that is not considered as a real protection. So true security should not depend on hiding the key. It should depend on strong locks, for example, or on access controls. Okay, so the core idea here again is that hiding something is not the same as protecting it. There is a huge difference. So this is a more technical example here of security, and this one mainly involves code uh, uh, obfuscation. So some developers make like their JavaScript code difficult to read by changing variable and method names in short or meaningless like letters. Like you will find something or a variable called A, another one called B, C, and so on. So this technique does make the code harder to read and flow, and companies like, for example, Google used it uh, like in the same context. Now, obfuscation can provide some protection for intellectual property, and especially like, for example, since JavaScript code like must be downloaded to the user browsers to run. Okay, so however, it is important to understand, I would say, the obfuscation like does how it does not, I would say, eliminate vulnerabilities, but rather, like if we have, let's say, an attacker now, the attacker is, I would say, determined and skilled enough, and he wants, so he can still analyze, and if he wants to understand for sure the code, that even with these simple variables and this like changing the names and so on, he can still analyze or reverse engineering the code. And now with ChatGPT, even if you give him the code with even shorter variable names, it can even like return for you the original version. So for this reason, I would say this technique or obfuscation should never be relied as like on as the primary or the main security mechanism. Okay, so it can be used like, for example, let's say as an additional layer, but not as a replacement for proper security controls. Okay, so the idea is again, hard to read does not mean secure. Okay, and this is just an example. Okay, what we have here, we have the code obfuscation looks how it looks like in practice. So on the left, what we have is the original source code where variable and method names clearly like describe what the program is doing. So we can see on the right now, like the applying this technique, the obfuscated version of this like script. So what we say is the same code, and this is the version where meaningful names have been replaced with short and unclear, I would say, identifiers. So this transformation mainly makes the code harder to read and understand at first. Okay, but however, let's say it is important to notice that the logic of the program does not change, the overall idea and flow does not change. This, like the functionality is still there, and let's say is skilled. If we have a skilled attacker, he simply or easily can analyze or reverse engineer it. Okay, so this is why obfuscation should not be reliable or like or be used as a primary security measure. It may slow, okay, attackers down, but it does not eliminate vulnerabilities at the end. So overall, the obfuscation hides names and not behavior, because again, like this code, still we can understand the behavior of this program. Okay, Moving forward now, while code obfuscation can make like reading, writing, and reverse engineering program more difficult and time consuming, it does not make it impossible. Okay, so again, if we have determined like attackers with the right tools, I can say, and experience, can still analyze obfuscated like code. Another important like drawback of is that the obfuscation can raise security warnings. Some antivirus aware, like such as, for example, the AVG antivirus, may alert users when they encounter manually like obfuscated code. Because mainly the reason is that obfuscation is sometimes used to hide malicious behavior. Okay, so in addition, now certain major browsers like Firefox, for example, and Chrome may disallow like browser extensions that contain obfuscated code. So this means that obfuscation can actually reduce user trust or limit where code can be deployed. For these reasons, obfuscation should be used very carefully, I would say, and never relied on as the primary secure mechanism. Okay, so if you want to summarize this slide, let's say that obfuscation can backfire. Okay. Uh, Now, it's also important to note that obfuscation is not always used with bad intentions. Sometimes developers use code obfuscation to reduce the file size and to provide an additional layer of protection for their software. Okay, this happens widely, like between developers. However, this can still create kind of, I would say, unintended consequences for users. So the advantage now, or let's think, sorry, the average user may not expect their antivirus software to display warnings for what is actually, I would say, legitimate and harmless code, especially when it comes from a trusted company. And as a result, these warnings can confuse users and even discourage them from using like otherwise safe software. So this like reinforces mainly the idea that obfuscation should be used very carefully and in a transparent way, I would say. So we must like never use it as the main security mechanism again. Okay, so now moving forward, we have the ninth secure design principle, which is keeping security simple. So when developers now design security controls, they should avoid using like overly sophisticated or complex architectures. While complex solutions may look impressive, they often increase the risk of mistakes, misconfigurations, and hidden vulnerabilities. Okay, so in practice, simple and well understood like security mechanisms are usually more reliable than complicated ones. So this means that reusing components that are already known and trusted rather than, let's say, consistently reinventing security like solutions is also very important. Also, it means, I would say, avoiding unnecessary complexity in architecture and code. And also, instead, what happens is that centralizing security fundamentals as part of the system's design is also very important. So finally, security tools should be integrated into environments like developers already use, such as like, for example, the IDE itself, the like build systems, source repositories and bugs, tracking tools, and so on. So when security is simple and familiar, I would say, it is more likely to be used correctly and consistently. Sorry. So the idea is that complex security is often like fragile security. So now the last secure design principle, which is fixing security issues correctly, fix security issues correctly. So when a security issue is discovered, let's say, the goal is not just to make a problem disappear temporarily. No, developers must first determine the root cause of the issue. It's also important to identify, patterns, to identify what could be the reasons, okay, and the reasons behind the problem. Like, for example, we have many security flaws are not isolated. They are the result of repeated design or implemented choices. So once the root cause now is understood, the issue should be repaired properly, okay? Not like patched in a way that only treats the symptom, okay? So we need to to make sure that the root cause is properly, I would say, repaired, okay? So after the fix now, developers must test the repair very well, okay? And including they can do the regression testing to ensure that this fix that they did does not introduce new problems, because it happens most of the time. So if the application now uses common design patterns, the same vulnerability may exist in multiple systems or components, okay? Developers now need, to carefully identify and fix all affected areas, not just the first one that is discovered, okay? So fixing security issues mainly in the correct way or correctly helps prevent the same mistakes from repeating in the future. So the core idea is that quick fix is not secure fix, okay? So this is the idea of fix security issues correctly. And here we come to the end of our video. I want to thank you so much for watching, and see you next time. Thank you so much.